Hello everyone, my name is Sayed Mchine Banu and today I am going to discuss on the topic which is applications of machine learning in various domains. So let's go for it. So before going on the applications of machine learning, let's discuss about few terms which is artificial intelligence, machine learning and deep learning. Artificial intelligence, as the name suggests, we are providing the ability to a machine to imitate intelligent human behavior. Then we are having machine learning. As we can see that machine learning is nothing but the subset of the artificial intelligence. In machine learning we allow the machine to learn from the data and perform tasks without explicit instructions. Machine learning uses algorithms to analyze large amounts of data, then it identifies patterns and then it makes decision. Mainly machine learning is for making decisions by a machine. Then we have deep learning. Deep learning is nothing but the subset of machine learning that uses complex algorithms and deep neural networks to train a model. Now we are having types of machine learning. Mainly there are three types of machine learning, which is supervised learning, unsupervised learning and reinforcement learning. There is also fourth type of machine learning, which is semi-supervised learning, which is nothing but the combination of supervised learning and unsupervised learning. Then we are having types of machine learning, which is supervised learning. So in supervised learning, the machine or the machine learns from the data which is labeled. We are providing the labeled data to the machine and then it's going to give the output. For example, classifying emails as spams or not. We all know that. So supervised learning is like we are going to provide input raw data to it, which is labeled data. We are going to give different images of different animals, but they are labeled. Like we are going to tell the machine that it's this images of particular animal, this is for camel and this is for cow. Then it's the algorithm works and the processing is done, and in output if we are giving a particular image like which we have not given, we are providing a new image to the machine, then it's going to predict that this particular animal is either elephant, camel or cow. There are mainly two categories of supervised learning. One is classification and the other one is regression. Then we are having unsupervised learning. In unsupervised learning, we are providing unlabeled data to the machine, and it will identify different patterns and then it's going to group the unlabeled data. For example, customer segmentation in marketing. Let's see the unsupervised learning. Here also we are going to provide the data, but this data is unlabeled. We are not going to tell the machine that this is elephant or this is camel. Then the interpretation is done of the unknown data, algorithm works and the processing is done. Then in output it's not going to give the name that this particular animal is elephant or this particular animal is camel. What it's going to be do it's like it will cluster that we have given many images of different animals, then it will form a cluster of elephants, then cluster of camels and then cluster of cows based on the appearance of them and its features. It's going to differentiate and form groups. Mainly there are two categories in unsupervised learning, which is clustering and other one is association. There are many algorithms under clustering like K-means algorithm, mean shifted algorithm. Then we are having reinforcement learning, which is third type of machine learning. In this type of learning, we are interacting, like the machine is going to interact with the environment and it's going to receive either a reward or a penalty based on its interaction. So this is the diagram that shows the reinforcement learning. So there's an agent which is going to perform action on the environment, and based on the action it has performed, it's either going to get a reward or it's going to get a penalty. Now we are having applications. There are many applications of machine learning in various domains like healthcare, finance, retail, transportation, manufacturing and energy. So let's go into deeper to it. So the first one is healthcare. So in healthcare, the first one is the disease detection and prediction. Machine learning models can be used in early detection as well as prediction of diseases like cancer by analyzing medical data. So what's the machine learning is going to do? Machine learning model is going to analyze the medical data such as MRI reports or CT scans or blood tests, as well as it's going to go through the patient history in order to identify patterns that may indicate early signs of illness. As we all know that let's say a cancer is mainly detected at a later stage, and at later stage what the cancer has become malignant, like it has spread out to the different organs of the body, and it's difficult to treat a cancer at a later stage. But if it's detected at an early stage, then it's maybe possible to treat it like more efficiently. So ML models can be used in order to detect any small abnormalities also, like in MRI reports or in CT scans or as well as in mammograms. That small abnormalities can be unnoticed by humans, but this ML models can be used to predict it. Then we are having personalized medicines. These ML models can be used to suggest personalized treatment plans on a patient's medical history and its genomic profile. Then we can use ML models to adjust the drug dosages for individual patients in order to maximize its efficiency and minimize its side effects. Then we have drug discovery and development. So ML models can be used to predict the efficiency and safety of new compounds for faster drug development. It can also be used to identify suitable participants and predict its outcome. Then we have patient monitoring. So as we all know, wearable devices like smartwatches. Along with the smartwatches, machine learning models can also be used in order to track patients' vitals such as blood pressure, then heartbeat rate, then respiratory rate, which will provide early warnings about health issues, which will enable us to have proactive care, especially for chronic conditions like diabetes or hypertension. Then we are having application of machine learning in finance. So according to me, most important application in finance is fraud detection and prevention. So machine learning algorithms can be used to identify any unusual activity through the past history that we have. So by learning from the historical or the past history, these models can detect fraud more accurately and quickly than the traditional system. Then next we have credit scoring and risk assessments. So ML models can be used to evaluate credit worthiness by analyzing many factors such as social behavior, financial data, or the transaction history, which will lead to more accurate and inclusive risk assessments. Then we are having automated customer support. So ML powered chatbots as well as virtual assistants can be used in order to solve customer queries, or in order to process transactions or account management, which will improve the customer experience and reduce operational cost. Then we have market forecasting. So ML models can be used to predict the stock prices, which change every now and then. Then currency exchange rates and other financial market trends by analyzing the historical data, and it will help investors make informed decisions. Then we have next application of machine learning in agriculture sector. So the first one is crop disease and pest detection. It is like same disease detection and prediction in humans, but it can be used in agriculture sector too. So ML models can analyze images from the drones or field cameras to detect signs of disease, pest, and by identifying issues quickly, farmers can apply targeted treatments by reducing the use of pesticides and increasing crop health. Then next we have precision farming. So ML models can be used to optimize the use of resources such as water, fertilizer, and pesticides by analyzing data from the sensor, and this will allow farmer to apply more efficiently, reducing waste and cost while increasing crop yield. And next we are having weather forecasting. Weather forecasting is like we can use for agriculture. Like ML models can be used to analyze weather data and patterns to provide more accurate weather forecast, which is going to help farmer to make better decisions, like when to plant the crop, when to do irrigation and harvesting times also. Then we have soil health monitoring. So ML models can be used to analyze soil data like pH, moisture and other data to provide insights into the soil health and recommend the potential use of fertilizer and improve soil quality over time. Then we have weed detection and control. So ML algorithms can differentiate between crops and weeds in images captured by drones. Which will reduce the need for herbicides and labor, making farming more sustainable. Then we have next application of machine learning in retail. So the first one is personalized recommendation. So ML analyzes customer behavior, preferences and purchasing history to provide personalized product recommendation. We know that if a person is more interested in like if the person's history is past history is showing that he has purchased more like clothing items, then the recommendation system is going to show it like more cloth related products. uh, then we have demand forecasting. So ML models can be used to predict the demand for products based on the historical data. This will help in forecast. This forecasting will help retailers to optimize inventory management, reduce stockouts, and minimize overstocking, which will lead to cost savings. And we have customer segment analysis. So ML can be used to analyze customer sentiment from the post and the feedbacks to understand sentiment about a particular product, and this will help retailers improve customer service, identifying potential brand that the particular customer prefers. Then we are having application of machine learning in manufacturing. So ML algorithms uses data from sensors which are embedded in machines to predict when equipment is likely to fail. By identifying the potential issues before they occur, like before the failure occurs, manufacturers can perform maintenance proactively, which will reduce their repair cost. Then we are having robot control and automation. So ML models can be used to train industrial robots, which will be helping in assembly, packaging and material handling. It will require less labors, which will reduce the cost automatically. Then we are having supply and demand matching. So ML models can help manufacturers align production schedules with market demand by analyzing factors such as customer orders, inventory levels and lead times, which will be helping the manufacturer. Then we have next application of ML in energy. So first is energy demand forecasting. So ML models can be used to analyze historical consumption data, weather patterns, to predict future energy demand. This will help to plan better for peak load periods, optimize energy generation, and it will lead to prevent overloading power grids. Then one of the most important of its application is smart grid management. So ML can be applied to optimize the operation of smart grids, which can automatically detect faults, reroute power and balance loads in real time. So ML models can help improve grid efficiency, reduce downtime and manage every distribution more effectively. Then we have application of machine learning in transportation. So first one is autonomous vehicles. As we all know that ML plays a great role in it. Then we have traffic management and prediction. Machine learning models can be used to know where traffic is more and where the traffic is less. So according to that we are going to take the route. Then we have smart parking system, like where the parking is available, we can park our car there. So ML models can also be used in transportation there. So this were all about the different applications of machine learning. Hope you like it. Thank you.